Welcome to the Math 1 lesson summary video for the task Sum of One, None of the Other. This lesson is a Solidify Understanding task, which takes concepts developed previously and helps you formalize those ideas. The purpose of this task is to solidify the meaning of the x and y intercepts, the understanding that the rate of exchange is the slope of the boundary line, the understanding that the properties of equality allow us to move between slope-intercept and standard form, and that we can graph from either form of the equation. Carlos and Clarita are comparing strategies for writing equations of the boundary lines for their pet sitter constraints. They're discussing their work on the space constraint. Remember, the boundary line is made up of the set of points that meet the constraint exactly. That line separates all of the points or combinations, in this case of cats and dogs, that meet the constraint or satisfy the constraint, and those that don't. So it separates the points that meet the constraint or satisfy the constraint from those that don't. In this lesson, or in this task, you're asked to show the steps that you could use to turn Clarita's standard form of the equation into Carlos's slope-intercept form of the equation, and explain why you're able to do each of the steps that you need to do. The second part of the first question asks you to do the same thing, but now you're starting with Carlos's y-intercept form, and you're converting that into Clarita's standard form of the equation. We're going to be using the properties of equality to justify each of these steps. Remember that when we're solving algebraic equations, we must perform the inverse operations to both sides of the equation in order to keep it balanced and equal. When we look at the first one, we are starting in the standard form, and we need to convert it to this slope-intercept form by isolating the y value. So in order to get y by itself, we've got to get rid of or undo what's being done to y. And so the first thing that we notice is being done to y is it's being added by 6x. So we're going to do the inverse of that to both sides of the equation using the subtraction property of equality. We're going to subtract 6x from both sides of the equation, and we get 24y equals negative 6x plus 360. Now y is being multiplied by 24, so we're going to do the inverse operation, which is to divide both sides of the equation by 24. We're using the division property of equality here. We're then left with the slope-intercept form of Clarita's standard form of the equation. Next, we are looking to convert Carlos's y-intercept form back into Clarita's standard form. And because we are not isolating the variable, either of the variables, we have to take a little bit of a different approach. And there's different strategies that you can use to get from this form of the equation to the standard form. One way is to look at the different terms that make up this slope-intercept form of the equation. I notice that I've got a y term, an x term, and then I have a constant. And when I compare that to the standard form, I also have a y term, an x term, and a constant. And so if I look simply at my constant terms and ask myself, what do I need to do to this 15 to get it to 360? What can I multiply this by, 15 by, to make that equal 360? Well, if I divide 360 by 15, I find out that the quotient is 24. So if I multiply the 15 by 24, I'll get back to the 360. But I know that when solving algebraic equations or even just reforming them, I know that whatever I do to one term of the equation, I've got to do or apply that same operation and value to each of the terms in the equation. So if I multiply the 15 by 24, I have to also multiply this term and the y term by 24. And so we've set that up here. That's using the multiplication property of equality. In order to simplify this side of the equation, I'm going to use the distributive property, and I end up with this equation. Now, I know that I need to isolate the 360, so I'm going to do the inverse of what's being done to 360. Well, it's being subtracted, it's being added by a negative 6x. And so we're going to do the opposite, which is to add it by a positive 6x. But if we do that to this side of the equation, we must also do it to the left side. And when we do that, we're left with 6x plus 24y equals 360. Numbers 2, 3, and 4 are similar to what we just did in number 1. So you're going to apply the same strategies that we just went over, but this time you're going to do it using the equations that we developed in the previous lesson for the startup cost constraint. If you recall from the previous lesson, the standard form of the equation was 32x plus 80y equals 1,280, and the y slope-intercept form of the equation was y equals negative 2/5 x plus 16. We need to consider when converting from slope-intercept form to standard form, which number we're going to be multiplying both sides of the equation by so that we can turn this constant 16 into a constant 1,280. So again, using the same strategy that we just did in problem number 1, we're going to divide the 1,280 by 16 to find the factor that we're going to use for both sides of this equation. For problem number 5, we're being asked how we would be able to use Carlos's slope-intercept form to plot 2 points on his line. Well, we know that the x and y intercepts of a line represent situations where one of the quantities represented by an ordered pair, xy, is 0. The slope of a linear equation represents a rate of change, such as the exchange rate between cats and dogs. And so in this equation, we know that our slope is negative 1/4, and our y-intercept is positive 15. In regards to the space constraint, which this was the equation, this is one of the forms of the equation for it, remember that the slope, negative 1/4, represents that we are gaining 4 cat pens every time we decrease the number of dog runs by 1. So that's why one of these is positive and one is negative. So if we increase 4 cat pens, we're decreasing 1 dog run. Since 2 points determine a line, the graph of a line can be obtained by plotting both the x and y intercepts from standard form, or the y-intercept and a second point found by counting the ratio of rise to run as indicated by the slope. So in this case, we know that our y-intercept is positive 15. And so if we write that as an ordered pair, we know that our first or our starting point would be at 0, 15. And so if we plot that point first and then use our slope, which is to go down 1 and then to the right 4, we can plot our second point. We can then connect those points and extend our line. In our final question, we're being asked how Clarita might use her standard form, 6x plus 24y equals 360, to plot 2 points on her line. Clarita is really clever, so she looks for the 2 easiest points she can find. So we know, again, that there are multiple approaches and strategies that we could use, but given the hint that she wants to look for the 2 easiest points, we're going to take a specific approach that would not require us to convert this to slope-intercept form. So we know that when we're graphing points, where the line crosses the y-axis is called our y-intercept. And we know that the point where the line crosses the x-axis is called our x-intercept. We know that the y-intercept has an x value that is 0. We're going up on y, but we're not moving anywhere on x. So our x value is 0 for this point and for all points located on our y-axis. The same thing, actually, if we substitute the 0 that we know x is, if we substitute 0 for x and solve for y to find the y-intercept, we can use that to help us create our line. So taking her standard form of the equation, we're substituting the value of 0 in for x because we know that this y-intercept has an x value of 0. And then we're solving for y using our properties of equality. When I do that, I get y equals 15. So when x is 0, y is 15, and my ordered pair is 0, 15. We can take the same approach for the x-intercept. We know that the x-intercept has a y value of 0, and so it would look like this as an ordered pair. Again, we're moving on the x-axis, but we're not moving vertically on up or down, so our y value is 0. If we substitute that 0 in for y into the equation and solve for x, we'll be able to find our x-intercept. And so we're doing the same thing that we did over here, except now we're substituting the y for 0 instead of the x. When we do that and simplify and use our properties of equality, we get the solution x equals 0. We know that our y is already 0, and with that, we can create our second ordered pair. Once we have our 2 ordered pairs, our x-intercept and our y-intercept, we can connect those points to form our boundary line.